Hey guys, my name's Karan Daftari and I'm this guy.
And I'm Daniel Branton, and I am this guy. Okay, so we have here Neville's algorithm with 3 points. We want to draw a parabola through the 3 points that the user specifies. And for Neville's algorithm to do that, we use a line through AB and a line through BC. And the point that we want on the parabola to interpolate will be somewhere between those two lines at any given time. So we're going to assign A to time 0, B to time 1, C to time 2, and then calculate how far we need to walk from a point on one line to a point on the other to get to the point on the parabola. So that's how we use Neville's algorithm with 3 points. We use lines between the points to interpolate. If we had 4 points instead, which we want to add a 4th point with Neville's algorithm, now we no longer want to walk between 2 lines to get to a point on the parabola. We want to walk between 2 parabolas. So we're going to take the parabola from ABC, which is the dotted line here, and the parabola BCD, which is the dotted line here. And as you can see in the middle, the line that we want, which goes through all 4 points, is somewhere between the 2 parabolas. Here's the dotted parabola, and where we want. So to find P, we're going to start with a certain point on parabola ABC and add to it a certain amount of a point on parabola BCD, and that will give us the point on the parabola. Okay, so here we have our Neville's curve through 4 points. Whoa, just dragged the point way out there. Okay, and as you can see, the user can move these points around and it will interpolate the curve through all 4 points properly. So you can make whatever you want. A fish. And yeah, so that's that.
Alright, so the Neville's algorithm is used here to define this curve right here. So notice how there are 3 points on each line, and when you move any of these points, you can determine what the curve would look like. So as you can see, I'm turning the points around, it's sort of defining the curve at this particular moment. And when I press A to animate, you'll see cool things happening like this. And watch as at any point of the animations, you can actually change the way your curve looks. And the best part is when you want to really start amusing yourself with cool tricks here and there, you can always play with the curve while the curve's sort of animating. And as linear interpolations take place in real time, you can have the curve flipping, or you can have the curve sort of expanding and contracting, and all sorts of cool things that you can see here. Alright, so things even get more interesting when you start making 4 points instead of just 3 points. So let's actually go ahead and show something interesting here. As you can tell, using Neville's interpolation algorithms, it's already interpolating and changing the curve. And upon animating, you can see how it makes a loop, and obviously you can play around more with these and get you some cool looking animations. Now obviously that was using 4 points. Now this using 3 points, you really can't do anything like that. So we start animating here. Let's say if we wanted to do something even similar to sort of having like flips and making good animations, you really can. So that's like one big advantage of having 4 points over 3.